This is section 6.4, properties of rectangles, squares, and rhombi. Problem number 3, the got it, on page 378. It's giving us a measure for LN and for MO. Up here, the first step is equal to MO. That means that 4x minus 17 should equal 2x plus 13. So if we subtract 2x from both sides, 2x minus 17 equals 13. And if we add 17 to both sides, 2x equals 30, which means x equals 15 when we divide by 2. However, the problem did not ask for x. It asked for the lengths of the diagonals. We only have to solve for one to get that answer, but solving for both would just prove that we were correct and didn't make any mistakes. So if we do 4 times 15 minus 17, and that should equal 2 times 15 plus 13. So 4 times 15 is 60 minus 17 has to equal 2 times 15 is 30 plus 13. 60 minus 17 is 43. And 30 plus 13 is also 43. So the answer is that the diagonals are 43 long. And since we came out with both of them the same, that we know that we're correct. Part B says, what type of triangle is PMN? That's going to use the theorem that the diagonals of a parallelogram bisect each other. Yeah, parallelogram bisect each other. So that means that PM and PN are going to be congruent, because if in a parallelogram the diagonals bisect each other, in a rectangle we just talked about the diagonals being congruent. So if they were congruent and they bisect each other, that means that all 4 of these halves are going to be the same length. So if it has 2 sides the same, that we know for sure, what kind of triangle would we call that? So since the diagonals of a parallelogram bisect each other, and the diagonals of a rectangle are congruent, this means that PM, PN, LP, and OP are all equal or congruent. So since triangle PMN has 2 sides congruent, we call that an isosceles triangle.